For the first multiple choice, it says, if f is differentiable and a is a number, then f prime of a is given by which of the following expressions? And so if I look here, I can see this is a limit definition with h going to 0. I have f of h, a plus h minus f of a over h, so this is 1. So I know it's not that one. This is the limit as x goes to a, f of x minus f of a over x minus a. So that works. So it's not that one. It's not that one. And so now the question is, does 3 work? So this is the limit as h goes to 0, f of x plus h. F of x plus h minus f of x over x minus h. So what I'm seeing is that the denominator is backwards. And also, this is going to, if it were flipped around, it would give me f prime of x. What I'm wanting is f prime of a. So 3 is out, so it's just 1 and 2. The next one, it says the temperature of a 12-ounce cup of coffee, a type T, is given by that. That's the interpretation of T prime of 4.2. So remember, T prime of T gives the change in T per minute. So it tells us how much the temperature changes. For each additional, well, I guess it's an approximation, approximately. How much the temperature will change for each additional minute. Okay, so let's see what we have. 4.2 minutes after the coffee was brewed, the temperature of the coffee was that. So it's not that. It's not that this gives me the temperature of the coffee. Anyway, that wouldn't make sense because it's negative. And coffee is surely positive degrees Fahrenheit. The temperature of the coffee decreased by 9.85 degrees Fahrenheit during the 4th minute. That's close, but not quite. How about this? On average, the temperature of the coffee decayed by 9.85 degrees over the first 4.2 minutes. No, that's not right either, but it does talk about change in temperature. What about this one? 4.2 minutes after the coffee was brewed, the temperature of the coffee was changing at a rate of negative 9.85 degrees Fahrenheit per hour. There we go. That's what we want. Let's look at the last one. The temperature was 132.1 at 4.2 minutes. Now, where did that number come from? Maybe they plugged in 4.2 into that, which that might be true, but it's not relevant to the question. Okay, evaluate this limit. And so I think the thing to realize is that what this is this is the derivative of sine. Evaluated at pi. And so, we're going to use that fact. So I know that the derivative of sine is cosine. And if we evaluate that at pi, cosine of pi is negative 1. So the answer is C. So the next page, it says, I have a twice differentiable function. Which of the following is true? Okay. I was asking about f double prime, f prime, and f at 4. Well, the first thing I might see is that f of 4 is 0. And f of 4 is 0 because the y value of the function is 0 when x is 4. Okay, and what might I notice about f prime? Well, the function here is decreasing, so the slope is negative. So f prime of 4 is negative. And what about the second derivative? Well, the second derivative is related to concavity. And you can see that my function is concave up here. And since it's concave up, that means f double prime is positive. Okay, so now we should be able to order it. Since f prime is negative, it's the smallest. Should be less than f of 4, which is 0. Should be less than f double prime is positive, so it's the biggest. Alright, so let's see which one that works. That's B. Okay, next. Suppose that thing is true. F prime of 2 is greater than. Now what is this thing? This is the slope of a secant line. So this is the slope of a secant line. So it's like starting at 2, scooching over by delta x, and measuring that slope. Okay, so let's see. At 2, here's the slope of a secant line. And then the tangent line is that on top. So I would say it's not A. Let's draw the tangent line at 2 here. And I'll just draw the tangent line for each of these. Okay. And then for this one, if I draw the secant line, I get that. And for this one, if I draw the secant line, I get that. And for this one, the secant line and tangent line are equal. So it's not this one because secant and tangent lines have the same slope. Oh, hang on. Which way did it go here? Let's see here. For this, what I want is I want the slope of the tangent line. So we want that the slope of the tangent line is greater than the slope of a secant line. And if I look at this one, it looks like the tangent line is steeper than the secant line. They're both positive slopes, so actually A would work. Let's see if B works. So the slope of the secant line is less steep, so the secant line is greater. So the secant line has greater slope. So it's not B. Now the secant line has greater slope. Now it's less steep, but it's negative. So if you're less steep but you're negative, that means you're closer to 0, so you're greater. What about here? Here the secant line is steeper than the tangent line. So, and then this one, they're equal. So the answer is A.